And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and I've become too large. Let's shrink me down. There we go. That's a little bit more appropriate. Today we'll be talking about the sun, radio signals from extraterrestrials. The solstice approaches. First thing we're going to do is look at the sun, a regular feature of our Daily Space Weather videos. And thanks for everybody who has subscribed to the channel, shared on social media, etc. Here's one day of the sun in 335 angstroms. And let's jump into some data here. The 10.7 centimeter radio flux, which is the radio output from the solar outer corona, currently at 82 solar flux units. There's the 1 year chart. And welcome to cycle 25. Welcome to Neo-Renaissance. There are the graphs of sunspot progression for the last solar cycle and the radio flux for cycle 24 as well. And we've got some great helioviewer movies. We're going to show you about half of them at the beginning and half at the end. First, we're going to look at the view from Lagrange point 5. So here's the view from stereo A. That's where Lagrange point 5 is. And I'm expecting a coronal mass ejection on the opposite side of the sun. For you new viewers, the Earth is out in this direction from the view of stereo A. All right? Maybe not. There we go. Yes. The Earth is out in this direction from stereo A. And it's the best tool we use to see coronal mass ejections. So we see some buildup happening here on the opposite side of the sun. You can also see Venus moving around from the back of the coronagraph there. So first of all, here is the our first helioviewer movie, and you can see Comet Erasmus there in the upper right corner, and you can also see Mercury down here. So some great views of various different things from our instruments that we look at daily here on the Daily Space Weather. Next, I'd like to thank our patrons, the true source of funding for the content, as we make approximately nothing for these videos on YouTube. So please tell your friends, your foes, your science noobs, and science pros about the channel, share on your social media, etc. Please consider becoming a patron. Again, the true source of funding for the content. It's patreon.com/smAsho. Thanks to our patrons. Please join at the 3-month or higher level, as the $1 and $2 tiers will be eliminated by New Year's Day, the first day of the year of accountability, 2021. So following this year of clarity, we're looking forward to a year of accountability next year. Large coronal hole right in the Earth-facing zone there associated with the North Pole. No sunspots right now. Active region rising in the southeast. We'll show you close-ups of that later in the video. Here's a 171 angstroms view. The last was 193 angstroms. And here's a 304 angstroms view. This one is the ionized helium UV emission spectra. A very narrow band of the electromagnetic spectrum, part of the UV spectrum, 304 angstroms. And we're going to move on to a whole bunch more data. We're going to have a cosmology segment. Before we do that, we're going to invite you to join us tomorrow, because at 5:02 and 20 seconds, we will be streaming live. It'll be a YouTube exclusive, youtube.com/smAsho. So join us at that moment. That will be the moment of the solstice. We'd like to be the first channel to wish you a happy solstice. So make sure you check that out. Here's a countdown timer. What will you be doing with your final hours of autumn or perhaps spring? And thanks to our southern hemispheric viewers for also tuning in, leaving comments, etc. Check out our own websites. smAshomash.com. You can find our social media there, as well as links to our stores. Don't forget to enter the promo code smAsho on all orders at the Teespring stores to save 10% at checkout on all orders through Christmas. Thanks to our new subscribers over at YouTube. Thanks everybody who's been sharing the content as well as viewing it. Don't forget to view our playlists as we do more besides the daily space weather. We are currently streaming live to Twitch. Thanks to our new followers over there. Also, make sure you perhaps download the mobile app for Twitch. Twitch.tv/smAsho is our URL over there. We don't always stream live to Twitch. Today we are. Tomorrow will be a YouTube exclusive, so Twitch users, make sure you subscribe and press the notification bell over on YouTube. We've also got all kinds of playlists over there, such as Terms Defined, The Diamond Anvil, Too Hard to Smash, and our Smash Lights segments. So, yeah, it's the Smash News Network. Least busted name in news. And today we're going to do a cosmology segment because, well, there's some interesting stuff going on about cosmology, and we're not going to throw any dice. We spend a lot of time talking about X-rays on the channel, and we spend a lot of time monitoring certain objects such as Cygnus X3. And so here's the X-ray output of Cygnus X3, in case you're wondering. It's in a very moderate state right now. It's acting very normally. So there's the recent 30-day activity of that, and you can see it's sort of right in the meaty part of its range here. And we're waiting to see if that goes into an X-ray loud or back into an X-ray quiescent state. Today we're not really going to talk about X-rays. We're going to talk about radio emissions. So, here's an article on SciTech Daily about the first possible detection of a radio emission from an exoplanet. So now this is a hot Jupiter. This is not an extraterrestrial type radio emission. This is the kind of emission that a hot Jupiter would put out, as Jupiter-like planets have a massive magnetosphere. And for example, if you could see Jupiter's magnetosphere when you look at Jupiter in the sky with the naked eye, Jupiter's magnetosphere would be as large as the full moon. And so these planets are able to emit radio frequencies, and so that's a thing. So perhaps read this article. And that's not what the title of the video was referring to. I just stumbled upon this sort of accidentally while I was looking for the article that is cited in the title. And this is often what happens with science. Science often turns into a rabbit hole. So what we do is we look for answers to questions. We observe physical phenomena in the universe and we say, how could that be a thing? And then we end up down a rabbit hole, finding answers to all kinds of questions besides the one that we asked, which leads to what? More questions. So what we're talking about here is Proxima Centauri. Yes, probably the closest exoplanet, and it's only located a few light years away. And what's going on with this planet is a couple interesting things here. We've detected a radio emission that looks quite artificial, and folks have spent a long time trying to rule out earthly sources as well as satellites passing in between it. It was a 30-hour series of emissions. So now this planet is interesting in that it's likely tidally locked, which means it has a light side and a dark side. And some people think that's a reason why life wouldn't be there. But I would like to put up the theory that when you have a planet with a light side and a dark side, right on this line, you've got a sweet spot where you've got UV emissions and you've got cool enough temperatures for liquid water to happen around that area. It may be too hot and too much radiation on the constantly star-facing side of the planet, but the dark side, or perhaps right around the, quote, day-night ring, because one planet has eternal daytime and one side of the planet, one side has eternal daytime and one side has eternal nighttime. It's thought about Proxima Centauri b, I think it is. And my browser is not cooperating today. Anyway, this is the first serious candidate for extraterrestrial radio signals detected since the 1977 WOW signal. So this article's on Daily Wire of all places. If you want to go have a read on that, please do. It's also on our Facebook page. And I'll just let that scroll real quick. I don't want to spend too much time. It's only 4.2 light years away. And again, that Proxima b is an Earth-like rocky planet that orbits in a portion of the solar system which could feature liquid water on its surface. So perhaps ET has been sending out radio signals. Who knows? You can only hope. Perhaps it is coming out of the planet somehow also. Another theory as to where the radio signal could have come from. So that is interesting, I would say. Go have a read on that if you like. And there ends today's cosmology segment. It'll be integrated into today's daily space weather video, a normal feature of the Smash News Network. Next, we're going to look at more data. The real-time solar wind is next on the list. And as forecasted, we indeed see the solar wind density drop and the solar wind speed come up at the same time. So it looks like a coronal hole wind stream, but that's not the main feature of that large coronal hole in the north. I would expect another day for that to arrive. Perhaps it's from a different coronal hole, maybe one that wasn't quite so visible. But in any case, expect a coronal hole wind stream coming in the next day or two. That is a second pulse. So this one looks pretty weak, and it looks like it's basically subsided here. Current conditions are 368 kilometers per second for the solar wind speed. So those protons aren't moving so fast right now. And the current solar wind density, 4.27 protons per cubic centimeter. Not that many protons either. The KP index is at 2, having been only at 0, 1, or 2 over the past 3 days. Here's the magnetohydrodynamic pressure in the magnetosphere. This is Geospace Magnetosphere movie. It's 4 hours of data. We show this daily on the daily space weather videos. Since this data is not visible in the archive, we show at least 4 hours of the data every day. So we'll let that play through. And then we'll show you ground magnetic perturbations, both from the pole. And for you new viewers, thanks again for tuning in. This is the Earth's B field. So we're looking at ground level changes in the Earth's B field, which is why it says geospace delta B. When you see the word delta in science data, that means change in. So you're looking at changes in the Earth's B field. We're also going to show you the global view. And we do see some magnetism changes happening there over both of the North Poles, the Siberian and Canadian one. We see some pulses coming out of the equatorial region of the planet there. And I'll let this play through a second time as well. Just so you can see all of that, you can see pulses coming out of the Pacific Ocean there, as well as out of the Indian Ocean, some minor changes in the Earth's B field there, perhaps giving us some insight into how the Earth's geomagnetism is generated. Where does the Earth's magnetic field come from? Any ideas? Leave us a comment if you've got a theory. Or perhaps head to smashomash.com/forum. We've got a whole forum section on it. Geophysics, yes. Next, looking at the proton flux to see it's flatlined over the past 3 days. There's the 3-day graph. We were showing you the 1-day graph. And we see a small rise here, a steady increase over the last day and a half in the X-ray flux, most likely that active region rising in the southeast. We won't worry about it too much. And next, we've put up a star chart here. And if you're up before dawn, you may see Venus if you've got clear skies. And get ready for the Saturn-Jupiter conjunction, which will happen tomorrow evening, where Jupiter and Saturn will appear as one object in the sky. If you're scared and spooked about it, I don't know what to tell you. It doesn't seem very scary, as they're not even aligned with respect to the sun. They're only aligned with respect to the Earth's viewpoint. Nothing's going to happen. Nothing happened the last time 800 years ago either. If you're scared and spooked about it, I don't know what to tell you. We refuse to fearmonger on the channel. We prefer to provide accurate information and things with predictive value. In any case, that's where stuff is now. There's where stuff will be on the solstice. And there's where things will be in a week. And we see this lower reading here happening in the GOES magnetometer, once again as forecasted. That's a 3-day chart measured by the GOES 16 at the F ionosphere layer. And just give me one moment to check on the life of the stream. Thanks for leaving us a comment, Precious Lights. And you're very welcome for what we do, Precious Lights. Tell your friends and foes, science noobs and science pros. We need more Twitch followers, and especially more YouTube followers. Next, we're going to look at the Gong 2 data here. First, the top view ecliptic plane field plot. And you can see that the Earth is solidly in the green-colored, North Pole-oriented current sheet. Red current sheet is the South Pole-oriented portions. And you can see evidence of activity all on the other side of the sun here. So while we see a quiescent sun right now from the Earth's perspective, there's quite a bit going on from the perspective of stereo A. And you can actually see stereo A. It's right there. There's Lagrange point 5, and there's stereo B at Lagrange point 4. Next, the line of sight coronal hole plot, and you can see that North Pole-oriented coronal hole there. It's quite large. It's quite in charge. And there is a coronal hole wind stream on the way. So when you see the solar wind density rise again, that's the leading edge of that coronal hole wind stream. Here's another view of the same thing. This shows the sun's B field in blue, and it also shows the solar polar fields. Lastly, we'll look at the solar coronal magnetic field plot, the atmosphere of the sun, which is quite a turbulent place. And while the entire universe is not electric, the solar corona is quite electric. Leave us a comment if you have a theory as to where all those electrons come from. We've got theories. We won't cover it on this particular video. We'll have to save that for a cosmology segment, since this is the daily space weather. Next, we're going to talk electrons around Earth. We don't see any charging hazards. There's the 1-year chart of the relativistic electron flux, the greater than 2 mega electron volt electron fluence, and that's provided from solon.info. And we're expecting a downtick here. I would concur with this NOAA forecast. We don't see much lower levels than that really ever. Yeah, that looks like an accurate forecast to me. I would agree. Here's the 3-year chart of the electron flux. I mean a 3-day chart of the electron flux. And when we see coronal hole wind streams arrive, we typically see very low levels of electron flux. So we saw a minor coronal hole wind stream yesterday into today. And by, let's see, by tomorrow, within 36 hours, we should see a more significant coronal hole wind stream arrive from that large North Pole-oriented coronal hole. Next, looking at the visualization of the electron flux here. This shows you the thermosphere all the way down to your GPS handset. It'll tell you where you'll see GPS errors. And this is not looking particularly anomalous here. Some minor anomalies there over North America, as we usually see the electron flux at the highest levels around the equator. And here's just a diagram of the inner and outer Van Allen belts, as well as the altitudes in miles for things like GPS satellites, the International Space Station, etc. Here's a diagram of the atmosphere, and you see that red F over on the right side. That's for our new viewers. To quote Einstein, never memorize something you can look up, and it can be confusing trying to remember which layers of the atmosphere are where. Some people are visual learners, and that's for you. Keep in mind this one shows altitudes in kilometers, not miles, as on this diagram. Next, we're going to look at one slice, and this is the ionosphere layer. And this is a full day of information, courtesy of the Australian Government Bureau of Meteorology. It's looking a little bit anomalous here in the southern hemisphere. And one thing to remember, folks, tomorrow, at the moment of the solstice, the sun's rays will start heading back toward the north. So it'll be the most direct radiation in the southern hemisphere, and the sun will start returning to us in the north at the moment of the solstice, 5:02 and 20 seconds Eastern Time. Again, make sure you join us for that. Next, looking at volcanodiscovery.com to see which volcanoes are going off. Klyuchevskoye continues to erupt and produce a 23,000-foot ash plume. Abiko, 8,000-foot ash plume there. Suminosejima, 6,000-foot ash plume. Popocatépetl, still erupting. It's exploding indeed, producing a 20,000-foot ash plume. Fuego also exploding. Flight level 150, 15,000-foot ash plume. Sangay, Revenador, and Sabancaya all exploding, producing 20,000, 15,000, and 25,000-foot ash plumes respectively. Please do not attempt to pole vault, do a back handspring, or the triple Lindy as featured in Back to School over the Caldera. It could be a bad day for your gymnastics. Next, looking at earthquakes, and we see the continued drought of 6, 7, 8, and 9 magnitude earthquakes. It's really a drought and earthquakes period. But here's a deep one that happened yesterday at 13:42 Universal Time at the Philippines. And we are a little bit late coming at you today. It's because we slept in. I didn't get out of bed until 5 o'clock. Yes, 5 a.m. counts as sleeping in for me. Our normal time of getting up is classified. So not a lot of quakes, not a lot of bling. When I report quakes, bada boom, bada bing. There's a 4.7 at Papua New Guinea. Here's a 4.6 at Argentina. Those are both at depth. One about 100 kilometers, one over 230 kilometers depth. Deep quake strikes Afghanistan and Tonga only about 10 minutes later, 12 minutes later. So deep quake at Afghanistan at a 4.3, deep quake at Tonga at a 4.3. Afghani quake was about 200 kilometers, and the Tongan quake on the opposite side of the planet, not totally opposite side, but that Tongan quake, 347 kilometers. A deep quake strikes the Bande Sea at 5:13 Universal Time today on the 20th. That's December 20th, 2020. 12/20/2020. Deep quake strikes Argentina once again in the same spot, perhaps a precursor for a larger quake. If that one happened to the surface, it would be about a 5.3. And let's look at some more data. Here is the situation of the jet streams. And we see jet stream once again blowing backwards, going from east to west over the western Pacific, as well as the Indian Ocean, the northern, well, the equatorial portion of it. And we see some doubled up jet stream in the south. Next, looking at the western world's jet streams. There are the jets of the western world. Some more cold air being injected into the north central states of the U.S. And this kind of pattern here is the sort of pattern that creates snow in places like Libya and Morocco. We won't do a detailed forecast for that unless somebody requests it. And let me just check the life of the stream once again. Again, we are streaming live. It's twitch.tv/smAsho. Thanks to everybody that viewed there, as well as the YouTube premiere, or if you viewed in syndication. And keep in mind, we always view the videos. Since I'm not only smAsho, I'm also a client, and I'm the editor at large. So if I make a mistake, I usually put a comment. Next, we're looking at Lightningmaps.org, and that's showing us the worldwide lightning scenario. Not a lot of lightning right now. Some in the Gulf, some in the Central Atlantic. And some in the Mediterranean. Here's the GOES lightning mapper. And you see that oddly southeasterly moving string of lightning there in the Gulf of Mexico, as well as a bunch of low clouds. Here's a U.S. Doppler radar map, I think. This Doppler radar map brought to you by the smAsho News Network at massive personal expense and liability. As we wait for it to load, we are very patient. It's actually windy.com's pressure map. There's where pressure is now. And look at all the low pressure in the northern hemisphere. It's just one giant blob of low pressure. Anyway, that's where pressure is now. There's where we expect pressure to be at 1 o'clock, 1 p.m. tomorrow. About 8 hours into winter in the northern hemisphere. Very powerful low there off the west coast of southern Alaska. A very large and powerful low pressure system there. Looks like it's only 28.07 hectopascals. Or is it millibars? Or is it the same thing? I don't know. Anyway, here's the U.S. Doppler radar map, and it could be snowing on top of me right now. I hope it is. Maybe I'll have to go out and check as we upload the video to YouTube. Again, if you're on Twitch, make sure you subscribe on YouTube. Next, looking at the clouds. And check out the low clouds over the Atlantic once again. Giant blob of low clouds here. Just stagnating low clouds, making for colder days and warmer nights. Here's what's going on in the water vapor layer, I think. The water vapor map also brought to you by SNN, least busted name in news, the smAsho News Network. And that's okay, computer, we'll just wait. There we go. Man, oh man. Slower than molasses in January. All right. So there's the U.S. water vapor map. Oh my gosh. I don't know what you're thinking. There we go. Now we're back to speed. Yay! There's the cloud layer. There's the water vapor map. And you can see evidence of that cold air being splashed down from Canada into North and South Dakota. And getting stuck right here as it butts into this dry mass of air. That's a huge area of dry mass of air. Making for some cold temperatures in places like Oklahoma, the Texas stovepipe, and soon to be even colder in the Great Lakes region, it looks like to me. And stay tuned for bonus features, as we've got to show you the colorized magnetogram and the solar intensity gram, and wonder when I'm going to have anything on my screen besides a plain black screen. There we go. I know. You're still seeing the you're still seeing the SNN. All right, so here's the solar intensity gram to show you a 0 sunspots. Here's the magnetogram. And let's take a look at this active region here. Oh, I see more activity rising there, and that right there is going to be a sunspot. So, could not even see this when I did show prep today. That is a sunspot. I can tell by the amount of magnetism. Let's see if it shows up on the intensity gram. And we cannot yet see any umbrae there. Actually, I do. I can see umbra. So there you go. There's another sunspot. If anybody showed you it before that, I highly doubt it. New sunspot to be named, and it's big. The umbra is about the size of the Earth right now. So let's get to our HelioViewer movies here, as we've got some lovely HelioViewer movies once again. We're going to show you a close-up of the Southern Hemisphere. We're going to show you Comet Erasmus. and more, like a close-up of the coronal hole. If it starts to play, there we go. So there's the 171 angstroms view of the southern hemisphere. Great view of that new sunspot. Did you see the umbra? Has anybody reported it before us? If you think there are 0 sunspots, think again. That one will probably not get named until tomorrow, but in any case, it's already visible. Here's me vanishing. Here's the same area in 94 angstroms. And just give that a minute to initialize there. Come on, you can do it. You can do it. Don't dump the stacks. There's 94 angstroms. Here's a close-up of the latest sunspot. I believe that one is 2794. Is it 2794 or 2795, the next one? I don't know. Leave us a comment. Let us know. Again, never memorize something you could look up. Here's Comet Erasmus. It's in the upper right-hand corner of the LASCO C3 if you want to check it out yourself. Comet Erasmus. And it looks like we're going to see that for a couple more days there, as its trajectory will keep it in the LASCO C3. And last but not least, here's the coronal hole, which will be providing an increase in geomagnetism, probably in about 36 hours. So that's about it. Look for another video coming from us today, probably another YouTube live stream exclusive. Thanks again for tuning in, folks. Great view of that coronal hole there in 193 angstroms. Remember, stare at the sun, attempt to understand the physics. And no matter how much the government drives you to drink, don't drink it. If you do drink, don't drive. And since it'll never be now again, welcome to the Neo Renaissance. Visit our site, support the channel, share the videos, and may that solar wind be at your back.